There are several reasons why the manual for a clamp meter insists on disconnecting the test leads before taking a current measurement. Firstly, it is important to acknowledge that some clamp meters are true root mean square or RMS meters. These instruments measure the true RMS value of the current flowing through a conductor, regardless of the waveform shape. This contrasts with average responding clamp meters, which only measure the average value of the current. True RMS clamp meters offer greater accuracy compared to their average responding counterparts, but they are also more susceptible to noise. Consequently, the presence of noise on the line can lead to inaccurate readings. Disconnecting the test leads prior to measuring current helps minimize the amount of noise affecting the meter. The test leads can function as antennas capturing ambient noise. By disconnecting them, a potential source of interference is removed. Secondly, disconnecting the test leads safeguards the meter from potential damage. If the test leads are inadvertently shorted together while the meter is in current measurement mode, the meter could sustain damage. This is because the short circuit creates a path of very low resistance, allowing a large current to flow. This surge of current can overload the meter's internal circuitry, potentially causing permanent damage. Thirdly, disconnecting the test leads ensures accurate measurements. Improperly connected test leads can lead to false readings. This can occur due to a variety of factors, such as contact resistance, stray capacitance, or inductive coupling. By disconnecting the test leads, these potential sources of error are eliminated, resulting in a more precise measurement. The following reasons explain why it's important to disconnect the test leads when using clamp meters. It helps ensure accurate measurements, protects the meter from damage, and reduces noise. While it might be less critical with average responding clamp meters, it remains a good practice to disconnect the test leads before taking a current measurement. Firstly, disconnecting the test leads minimizes the risk of accidental short circuits. In current measurement mode, the clamp meter's internal circuitry is configured to handle the current flowing through the conductor being tested. If the test leads are left connected and accidentally come into contact with a voltage source, a short circuit can occur. This can damage the meter, the circuit being tested, or even pose a safety hazard to the user. Secondly, disconnecting the test leads prevents the introduction of extraneous voltage into the current measurement. When the test leads are connected, they can act as antennas, picking up stray electromagnetic fields. These fields can induce a voltage in the test leads, which can then interfere with the current measurement. This is especially true in environments with high levels of electromagnetic interference, such as near motors, transformers, or radio transmitters. Thirdly, disconnecting the test leads reduces the possibility of ground loops. A ground loop occurs when there are multiple paths to ground in a circuit. This can create circulating currents that can interfere with measurements. When the test leads are connected, they can provide an additional path to ground, increasing the likelihood of a ground loop. Fourthly, disconnecting the test leads simplifies the measurement process. With the test leads disconnected, the user only needs to focus on clamping the meter around the conductor being tested. This eliminates the need to worry about the position of the test leads or the possibility of them coming into contact with other components. Fifthly, disconnecting the test leads protects the meter from overload. In current measurement mode, the clamp meter has a maximum current rating. If the current flowing through the conductor exceeds this rating, the meter can be damaged. By disconnecting the test leads, the user can ensure that the current flowing through the meter does not exceed its maximum rating. Sixthly, disconnecting the test leads prevents the meter from drawing excessive current from the circuit being tested. Some clamp meters have a relatively high input impedance in current measurement mode. This means that they can draw a significant amount of current from the circuit being tested, especially if the circuit has a high impedance. This can affect the accuracy of the measurement and can even damage the circuit. By disconnecting the test leads, the user can minimize the amount of current drawn from the circuit. Seventhly, disconnecting the test leads prevents the meter from acting as a load in the circuit being tested. When the test leads are connected, the meter can act as a load on the circuit, drawing power from it. This can affect the voltage and current in the circuit, leading to inaccurate measurements. By disconnecting the test leads, the user can eliminate this loading effect. Eighthly, disconnecting the test leads protects the meter from damage due to electrostatic discharge or ESD. ESD is a sudden flow of electricity between two objects with different electrical potentials. This can damage sensitive electronic components such as those found in clamp meters. By disconnecting the test leads, the user can reduce the risk of ESD damage. Ninthly, disconnecting the test leads is a good safety practice. Even if the meter is designed to be used with the test leads connected, it is always a good idea to disconnect them when they are not in use. This prevents accidental contact with live circuits and reduces the risk of electric shock. Tenthly, disconnecting the test leads extends the life of the meter. By reducing the risk of damage from short circuits, overloads, ISD, and other hazards, disconnecting the test leads can help to extend the life of the meter. For average responding clamp meters, while the need to disconnect the test leads is less critical compared to true RMS meters, the benefits remain pertinent. Even with average responding meters, disconnecting the test leads contributes to improved accuracy by minimizing noise and extraneous voltage. It also provides a safety margin against accidental short circuits and protects the meter from potential damage. The general rule of thumb is to always disconnect the test leads before taking a current measurement with any clamp meter. Following this practice ensures both accuracy and safety. It is important to consult the manufacturer's instructions to see what they suggest. The clamp meter measures current by sensing the magnetic field around a conductor. When the clamp is closed around a wire carrying current, it concentrates the magnetic field within the clamp's core. A sensor inside the clamp then measures the strength of this magnetic field, which is directly proportional to the current flowing through the wire. The meter then displays the current value on its screen. In contrast, when measuring voltage or resistance, the test leads are used to make direct electrical contact with the circuit being tested. The meter then measures the voltage difference or resistance between the two test points. Because current measurements with a clamp meter do not require direct electrical contact, there is no need to have the test leads connected. In fact, having the test leads connected can actually introduce errors into the measurement, as previously discussed. There is one exception to the rule of disconnecting the test leads before taking a current measurement. Some clamp meters have a feature called inrush current or peak hold. This feature allows the meter to capture the maximum current that flows through a circuit when it is first turned on. This is useful for troubleshooting circuits that have intermittent problems or that draw a large amount of current when they are first energized. When using the inrush current or peak hold feature, it is necessary to have the test leads connected to the circuit. This is because the meter needs to be able to detect the voltage across the circuit in order to determine when the inrush current occurs. However, even when using the inrush current or peak hold feature, it is still important to take precautions to avoid accidental short circuits or other hazards. Be sure to use insulated test leads and to avoid touching any live parts of the circuit. Also, be aware of the maximum current rating of the meter and do not exceed it. In summary, disconnecting the test leads before taking a current measurement with a clamp meter is a good practice that can help to improve accuracy, protect the meter, and ensure safety. There are a few exceptions to this rule, such as when using the inrush current or peak hold feature, but even in these cases, it is important to take precautions to avoid hazards.